What volume of a 0.15 m barium hydroxide solution is needed to completely neutralize 47 milliliter of a 0.29 m HNO3 solution? What volume of a 0.15 m barium hydroxide solution is needed to completely neutralize 47 milliliter of a 0.29 m HNO3 solution? The chemical equation HNO3 plus barium hydroxide, we get barium nitrate plus H2O. This chemical equation is not balanced. First of all, we need to balance this chemical equation. Let's balance it. Then on the left hand side, 2HNO3 plus barium hydroxide. On the right hand side, barium nitrate plus 2H2O. On the left hand side, 4 hydrogens. On the right hand side, 4 hydrogens. On the left hand side, 2 nitrogens. On the right hand side, 2 nitrogens. On the left hand side, 8 oxygens. On the right hand side, 8 oxygens. On the left hand side, 1 barium, and on the right hand side, 1 barium. Now you can see the ratio. To react with 2 moles of HNO3, 1 mole of barium hydroxide is required. In the same way, to react with 1 mole of barium hydroxide, 2 moles of HNO3 are required. We know the molarity and volume of this HNO3 solution. Therefore, we can find the number of moles in this HNO3 solution. Volume of this HNO3 solution is 47 milliliters. Volume 47. Molarity of this HNO3 solution is 0.29. 0.29 m. M means molarity. That means in 1 liter or 1000 milliliters of this barium hydroxide HNO3 solution, there are 0.29 moles of HNO3. In 1 liter or 1000 milliliters of this HNO3 solution, there are 0.29 moles of HNO3. In 1000 milliliters of this HNO3 solution, there are 0.29 moles of HNO3 because this is 0.29 moles of because this is 0.29 m HNO3 solution. Therefore, in 1000 milliliters of this HNO3 solution, there are 0.29 moles of HNO3. Then in 47 milliliters of this HNO3 solution, how many moles of HNO3 are there? We can find the answer in this way. 0.29 mole HNO3 divided by 1000 milliliters HNO3 multiplied by 47 milliliters HNO3. 0.29 mole HNO3 divided by 1000 milliliters HNO3 multiplied by 47 milliliters HNO3. We should cancel out unit. Milliliter HNO3. Milliliter HNO3. Now we get 0.01363 moles of HNO3. In 47 milliliters of this HNO3 solution, there are 0.01363 moles of HNO3. We know the ratio. To react with 2 moles of HNO3, 1 mole of barium hydroxide is required. To react with 2 moles of HNO3, 1 mole of barium hydroxide is required. Now we have 0.01363 moles of HNO3. Then to react with 0.01363 moles of HNO3, how many moles of barium hydroxide are required? We can find the answer in this way. 1 mole barium hydroxide divided by 2 mole HNO3 multiplied by 0.01363 360 moles of HNO3. 1 mole barium hydroxide divided by 2 mole HNO3 multiplied by 0.01363 moles of HNO3. Units should be cancelled out. Mole HNO3, mole HNO3. Then we get 0.006815 moles of barium hydroxide. We know the molarity of this barium hydroxide solution 0.15 m. Molarity of this barium hydroxide solution is 0.15 m. That means in 1 liter 1000 milliliters of this barium hydroxide solution, there are 0.15 moles of barium hydroxide. In the same way, there are 0.15 moles of barium hydroxide in 1000 milliliters of this barium hydroxide solution. Then 0.006815 moles of barium hydroxide in how many milliliters of this barium hydroxide solution? 0.006815 moles of barium hydroxide in how many milliliters of this barium hydroxide solution? We can find the answer in this way: 1000 milliliters barium hydroxide divided by 0.15 moles of barium hydroxide multiplied by 0.006815 moles of barium hydroxide. 1000 milliliter barium hydroxide divided by 0.15 moles barium hydroxide multiplied by 0.006815 moles of barium hydroxide. Units should be cancelled out. Mole barium hydroxide, mole barium hydroxide. Then we get our answer 45.43 milliliters. Volume of this barium hydroxide solution is 45.43 milliliters. Second method. There are two chemical solutions here. One is HNO3, the other one is barium hydroxide. We can take HNO3 solution as number 1 solution and we can take barium hydroxide solution as number 2 solution. There's no problem. If we want, we can take HNO3 solution as number 2, barium hydroxide solution as number 1. There's no problem there. Now we have taken here HNO3 solution as number 1 solution. Therefore, we can take molarity of this HNO3 solution as M1 and volume of this HNO3 solution as V1. We have taken barium hydroxide solution as number 2 solution. Therefore, we can take molarity of this barium hydroxide solution is as M2. Volume of this barium hydroxide solution is as V2. We know M1, it has been given 0.29. We know V1, it has been given 47 milliliters. We know M2, it has been given 0.15. We don't know V2. We need to find it. Now we can create an equation like this. M1V1 equals M2V2. Units are same on the left hand side and right hand side. Now we can substitute these values to this equation. 0.29 times 47 M1 0.29 V1 47 milliliters equals M2 0.15 V2 we don't know. This is the ratio. To react with 2 moles of HNO3, 1 mole of barium hydroxide is required. Therefore, we have to multiply barium hydroxide side of this equation by 2. Zero 0.29 times 47 equals 0.15 times V2. We have to multiply barium hydroxide side of this equation by 2. Then 0.29 times 47 equals 2 times 0.15 times V2. 0.2940 times 47 equals 2 times 0.15, 0.3 times V2. Here we need to find V2, therefore we should isolate V2 on the right hand side of the equation. Then 0.3 goes to the left hand side. In this way, 0.29 times 47 divided by 0.3 equals V2. By simplifying this, we can get our answer. We can find our answer V2 45.43. Volume of this barium hydroxide solution is 45.43 milliliters. Thank you very much for watching this video. Please subscribe our channel. God bless you.